And I'm going to pull up an evaporating cloud. So it's called a conflict resolution map. And this is a very simple template for an evaporating cloud. And this is a technique you use to resolve conflicts. And it's a model of kind of a generic model of all conflicts. And generally speaking, the idea of a conflict is you say you want something and I say I want something else, and those things are in conflict to each other. They can't both be satisfied. And the way that the evaporating cloud models the conflict is you need to step back and first identify your common objective. Why we even need to cooperate with each other, because if we don't need to cooperate with each other, there's no conflict. We just go our separate ways. So to understand it from that perspective, you have to realize that wants serve needs, which serve the common objective. And this is using not the sufficient cause thinking, but the necessary condition thinking. And you can see that because the entity operators and. That means to satisfy this, both of these things have to be true. They're necessary conditions, but neither of them by themselves is sufficient to cause to bring the common objective into being. The default juncture operator is or. So this is actually a reverse of how phonologic documents are set up by default. And now you notice that there's an edge here that is red, and that basically is what's called a negative edge weight. And if I actually zoom out a little bit here, and then if I turn on this button next to the confidence spinners, it's called edge weights. It shows me a spinner on every one of the edges that represents the weight of the edge. And by default, they're all black, which is positive, but this one has been reversed negative. And of course, I can move this from negative to positive as well. You can also right click on an edge and just say, set it to positive or set it to negative or set it to neutral even if you ever need that. So I'm going to set it back to negative because this is actually really important. I'm going to hide the edge weights in a moment. But as you can see, it's still, the edge weight is still visible because of the color of the arrow. But I'm going to turn on the confidence spinners. And as you can see, the only driving entity here is the conflict itself. All right. So remember, you can't adjust these manually. You can only adjust this one manually. And right now, the true value here, true flows through here and makes your want true, but the negated edge weight means that my want is false because they can't be satisfied simultaneously. So if I start moving towards maybe, then both of those start moving towards maybe. In fact, the common objective starts moving towards maybe. But then as I continue, well, the common objective is now false. Now I'm getting what I want, you're not getting what you want, and the common objective is again not met. So no matter which way I set this, the common objective is not met. So that's kind of what I think was a pretty vivid kind of way of demonstrating the nature of a conflict. So to actually solve a conflict, the reason why the technique is called the evaporating cloud is that if you can break any of these constraints between these elements, then the cloud evaporates, the conflict goes away. And this is designed to help you understand a conflict from a creative point of view. So you generally do that by surfacing all the assumptions under the arrows. And you first of all understand the needs that serve the common objective. So this is what I say, this is what you say you want. This is what you really need that serves the common objective. So you want this because you need this to serve the common objective. I want this because I need this to serve the common objective. And every one of these edges has underlying assumptions. And phonologic is a feature that lets you turn on all the edge annotations as blanks. So once you've done this, then you can actually press the tab key on an edge and edit the text inside each edge by itself. So for example, now you can see the text there. It's also directly editable on the edge. And part of the technique is to actually go through each of these edges and say, okay, I want this, but here's why I need it. So this is what I want. This is what I need, but here's why this want satisfies this need. Here's why this want satisfies this need. Here's why this need satisfies this common objective. And notice that if I turn this off, it just reverts back to the bullet. So this overrides, actually I can like right click on an edge and say show selected edge annotations, and it will just show them one edge at a time. So if I just want to show selected edge annotations, I can do that. If I want to create like another edge annotation here, I can do that. And this just shows up as a bullet because I haven't turned on show selected edge annotations. But when I turn them all on using this button, they all appear. And that's very useful for a technique like this, where you're going to want to put something on every edge. Now, so I'm going to hide the annotations for the moment. And in fact, I'm going to hide these. I'm going to select these two edges and tell it to hide them directly as well. So now it's all just more easy to look at. So, so how do we solve the conflict? Well, one possible way, for example, is to suggest that there's another way of meeting my need that doesn't meet my want. So, for example, that if I add this as a solution, I can basically, I'm going to basically set the add edit entity predecessor switch to add it as a successor. I'm just drag the solution to the edge. There we go. So now what I've done is I provided an alternative, and notice that the new juncture that's created is or. So basically I can either meet my want, which, again, this doesn't get us what I want, or we can meet your want, which serves your need, and we can implement the solution, or injection as it's sometimes called, and meet my need, which meets the common objective. So there's a number of different ways of solving the conflict. Notice that the cloud itself the conflict itself no longer exists. In this case, you get what you want, serves what you need. We implement the solution, which gives me what I need without my initial want being satisfied. So in this case, there's no more conflict. So this is one way of modeling the resolution of a conflict. And this is, again, you check your results using the spinners. You use, instead of and junctures, you use or junctures in this, because you're basically saying this and this are not individually sufficient to cause the common objective, but they're both necessary and together sufficient.